So I remember that I showed you the structure itself, that this is a galvanic cell. This is a metal. This is gonna be another metal. And here we're gonna have our salt bridge. So this is a salt bridge. And both these solutions. So basically, this is your solution one. So let's just write one here. And this is your solution two. So basically what's going to occur is that electrons are going to be transferred either from solution one to two or from two to one. And the transfer of electrons is going to cause a charge. It's going to create a charge. And that charge is going to cause, is going to, is going to, is going to cause the voltmeter to measure a reading. So basically, that's the reason why here it's a voltmeter. So in a galvanic cell, the chemical reaction itself creates electric current. But in a electrolytic cell, instead of a voltmeter here, you're gonna have a battery. So in an electrolytic cell, the current causes the chemical reaction to occur. So I think that's just the basis of the cells. But now we're gonna have to actually go deep into the questions and the equations. So in this section, I think the only equation that you guys are gonna use now is the cell potential is equal to the reduction potential of the cathode minus the reduction potential of the anode. So basically, at your level, you guys are just gonna focus on this single equation. So now we're gonna go through the question. So they say the electrochemical cell illustrated below is set up under standard conditions. So you should know what standard conditions are. And basically, if they say standard conditions, that means the cell potential, your equation is something like this. It's gonna have this zero up there to indicate that it's under standard conditions. So standard conditions, you guys are mostly gonna hear the word STP, standard temperature and pressure. So if they say it's under standard conditions, that means it's at STP, which is 1 atmosphere, 22.4 liters per mole. That's gonna be a molar volume. And your temperature is 273 Kelvin. Because if I remember well, you guys are gonna use 0 degrees Celsius as a standard temperature. So basically, I think that's everything that you need to know. So for today, we're gonna go through the question together. Yeah, I think we have enough time to go through the question together. So basically, they say component X completes the circuit in the cell. State one function for component X. So, if do you remember why a salt bridge is included in a galvanic cell? Sorry, do you know what's the function of the salt bridge?
Is it to keep it neutral, sir?
So you said it's to keep it neutral. So by neutral, what do you mean by neutral? Because it's a cell with a reaction occurring. So you can't just say it's to keep it neutral. Is it to keep the cell or the circuit or the reactions neutral?
It's to keep the whole solution neutral, isn't it, sir? Because it's like a spectator ion, and then it goes into the half cells to preserve to keep it neutral.
Okay. But what you said, it's not wrong, but it's not 100% right. But for me, I only know like one function for the salt bridge, so I'm gonna tell you mine. Then maybe I can just search it right now, so it can pop up. So maybe you'll remember it from class. So basically, let me just do this before I search it. Basically, this is a reaction, right? And a chemical reaction has to reach an equilibrium. So basically, the salt bridge is there to deposit ions so that this reaction never reaches its equilibrium point. So basically, it's so that if let's say magnesium is your anode, that means the magnesium ion, the magnesium metal is gonna how do I say this? It's gonna lose some of its mass, and it's gonna change into ions and get absorbed into the solution. And the salt bridge helps to transport those electrons. So basically, when M becomes Mg2 plus, it's gonna lose 2 electrons, right? So it's gonna lose 2 electrons. Those electrons will be transported via the salt bridge to the platinum. Meaning that this metal is gonna lose its mass. So its mass is gonna decrease. So its mass is gonna decrease. Its mass goes down on the anode. But on the cathode, the mass is gonna go up because it's gonna receive electrons. That's why we say it's reduced, and this one is oxidized. So basically, the salt bridge is there to help transport them, but it's also there to make sure that the solution never reaches an equilibrium point where the magnesium metal stops losing its mass. So basically, that's the function of the salt bridge. I'm not sure what I said makes sense, but I think it should. So let's go online. Function of the salt bridge. So yeah, here they say it prevents or minimizes the liquid to liquid conjunction potential. The salt bridge acts as an electrical contact between the two half cells. So as an electrical contact, that means like it's gonna help for the electrons to move, and it prevents the diffusion or mechanical flow of solution from one half cell to another. So basically, it also prevents this solution from the solutions from mixing. I don't know, like I think that makes sense. But anyway, so that's gonna be our answer for 8.1. You can just say it prevents both solutions from mixing, it transports the electrons, it prevents it from reaching its equilibrium point. But anyway, let's go to 8.2. They say define the term anode. So as I've told you, the galvanic cell is made up of two metals. One of them is going to be the cathode and one of them is going to be the anode. So do you know how to define the anode? So in this particular case, in this case, we can just say the anode is the metal that is oxidized by the cathode, or let's say the metal that loses electrons to the cathode. So it just depends on how you want to define it, but at the end of the day, the anode is the one that donates electrons to the cathode. So the next question is, I identify the anode in the cell above. So in order to identify the anode, there's two methods you can use. One, you can just look at the cell and say magnesium is oxidized to Mg2+, meaning that magnesium is going to lose electrons, making it the anode. Or you can go to your half reaction graph, which is, where's the half reaction graph? Let's look, and then we can look for magnesium. So your magnesium is here, and platinum. I think the formula for platinum is PT, and your platinum is here. So just from the looks of it, platinum has a higher oxidizing ability than magnesium. Because if you look at if you look at the statements from the side, they say increasing oxidizing ability and increasing reducing ability. That means magnesium is more able to reduce other metals than platinum, meaning that magnesium is most likely gonna reduce the platinum. So since magnesium is gonna reduce the platinum, your magnesium is gonna be your anode, since it is the one that's gonna lose electrons to the platinum. I don't know if you understand that. Does it make sense?
Yes, sir.
Okay. So they say write down the reaction half reaction, that takes place in this cell. And basically for the reaction half reaction, the reduction half reaction, you have to look at the one that is reduced. And in this particular case, it's going to be platinum. So you're just going to take this equation as it is and write it as your reduction half reaction. Since platinum is going to be the one that's reduced. If they wanted the oxidation half reaction, you're going to take the equation for magnesium. But instead of writing it straightforward, because it's something like Mg2 plus 2 electrons is going to give you Mg. So instead of writing it like this, because this is your reduction half reaction, if it's going to be an oxidation half reaction, it's going to change from this to this. So I just hope that you keep that in mind. When they want the oxidation half reaction, you take it as it is from the table. If they want the oxidation half reaction, you take it from the table, then you reverse it. If they want the reduction half reaction, you take it as it is from the table. So they say name or formula of the reducing agent in this cell. So the reducing agent is the one that oxidizes the oxidizing agent. I'm sorry. The reducing agent is the one that reduces the oxidizing agent. Basically, the reducing agent is the one that receives electrons. So in our particular case here, we have platinum. Platinum has to be a reducing agent in this cell. Oh, I'm sorry. Can we go? Can I just do this? Sorry. Your reducing agent is the one that reduces the oxidizing agent. So the reducing agent is the one that loses electrons. So basically, these words, they're a bit more, they're a bit scrambled. So you have to be careful with these words, like oxidizing agent, reducing agent, reduction, oxidation. So basically, your reducing agent is gonna be Mg. Yeah, it's gonna be Mg. because it's the one that causes the platinum to be reduced. So your reducing agent in this, your reducing agent is the one that's gonna lose electrons. So Mg. So they say calculate the initial voltmeter reading under standard conditions. So in this case, you're just gonna use E cell is equal to E cathode minus E anode. So this is gonna be, so first we're gonna check the one for platinum, which is for platinum that's positive 1.2. So here we're gonna have positive 1.2 minus into, now we're gonna check the one for magnesium, which is negative 2.36 into negative 2.36. So your answer is gonna be 2.20, 1.20, 2.36. Your answer is gonna be 3.56 volts. So that's gonna be the initial reading of the voltmeter. So now they say the magnesium half cell is replaced with a copper half cell, and it is found that the direction of charge of electron flow changes. So they want us to explain why this happens. So basically, you're gonna go to your table and look for platinum and copper. So as you can see, platinum is 1.20 and copper, which copper did they use? Which copper half reaction did they use? Cu2 plus. Okay. For copper is positive 0.34. So basically, from what they're saying, when the direction of the electron flow changes, that means copper has a higher oxidizing ability than platinum. So if it has a higher oxidizing ability, That means platinum is now going to become the anode and copper is going to become the cathode. So the electrons are going to start moving from platinum to copper. Basically, that's the reason why the electron flow, why the direction of the electrons change. So basically, this is it. This is question 8. I don't think it's gonna be that difficult, but mostly from from my perspective, I think you guys should study so you can find it easier.